Okay, so today's lesson is all about graphing the derivative. Last year, I would give you a graph just like this and ask you to graph the derivative. So this isn't anything different. However, you will see that we will even move into questions eventually about where I give you the derivative and I ask for the original. And that will get a little tricky, but keep in mind these two major steps of how to graph derivatives. The first step is always to find the maximum and minimums. Why is that? What do we know is happening at the maximums and the minimums of any graph? Let's just take a look at this first graph that you see here. The minimum here and the maximum. What do we know about the derivative? Keep in mind the derivative is what? Slope. F prime is basically saying what is the slope at that spot. So maybe we might even pause for a moment from this little lesson and say to ourselves, okay, what do we know about slope? What do you know? And maybe even at this point, you might pause the video for yourself and literally write down what are the four major things that you know about slope. Let me help you out. Okay, if I have a slope that is going straight, left to right, flat, what does that mean? What kind of slope is that? Zero? Great. If I have a slope that is going up and down, so I have a line, what is the slope of this line when it's moving up and down? Undefined, or what's another term? No slope. If you remember from last year, or maybe I didn't even, I think I did talk about this, but if you look at the side of the end, it runs up and down just like the line does. And if you were to write out the word zero, I'll even use that little zero, the top of the Z runs left to right, just like the line. So if you ever get those confused, that is a quick trick as to what is going on there. Two more cases that I want to just quickly look at, and that is, of course, this kind of slope. What kind of slope is that? Excellent. And how about the other one? Would be, of course, negative. Knowing those things, I want you to think about this. So zero slope is when it's flat. Now remember, when we're talking about the derivative, I'm looking for tangent lines that are flat, or no slope, or positive, or rather increasing, or negative, or decreasing. So now let's go back to that question. Our first job is to find the maximums and minimums. So I've already done that. I've found them. So what do we know about the slope at that spot of the tangent line? If I was to draw that right along there, you would see quite simply that the slope at the maximum minimums is in fact zero. So what we do is we put a point on our x-axis at 0. The next thing is you determine from left to right, just like how you read a sentence, from left to right, if it is increasing or if it is decreasing. That's your second step. So increasing or decreasing. So let's just look here. Here's where I'm at. What is it doing to get to this spot? From left to right, left to right. It is going down or decreasing. That would mean that the slopes of the tangent line would all be negative. So this part would be below the x-axis, meaning that the value of that slope is in fact negative, so it would be below. How about from this point to this point, from the minimum to the maximum? What kinds of slopes are along there? Positive. So they would all take on positive values. Now, more specifically, if I was to look at this, you would notice that it's kind of slow here, and then it increases substantially, and then it slows down again. It starts to flatten out. So the way that this ends up looking is from this spot here, where that minimum is indicated, its slope anyway, to where the maximum slope is indicated, you're going to basically hook the two together above the x-axis because they're positive, and it would indicate that the slope closest to that minimum is slow or low in value. And as we get to this spot here in the center, what we'll later learn is called the point of inflection, it's where the slope is the highest. And then again, it starts to slow down again. It's It's like your minimum and your maximum speed. Think of your pushing on the accelerator. As you are kind of accelerating, you push fast, you start slow, and then you kind of let off once you get to that spot, the maximum speed, and you hold it there, or you don't. Okay, now, how about, we've arrived at the maximum, we've got this part of the graph, now we look and these slopes here are negative or going down. So this is a little sloppy, so I'm just going to erase this just so I can write it more neatly. But basically, I have my minimum and maximum. I would have down, I would have up, and I would have down. It looks like an upside down parabola. Excellent. All right, let's look at this next one. The next example that I have for you, if you're asking yourself that first question, it should be, where is the maximum and minimums? And then you say to yourself, there isn't one. Good. So this one poses its own little issue because we don't have a place to start from necessarily. So what we're going to do is we're going to work left to right. And I want you to think, just practically speaking, what's the kind of slope? What's it doing? Is it increasing or is it decreasing? As we start from this little spot of the graph, what kinds of slopes are these? And more particular, what would be like their value? Would they be high? Would it be a very steep slope? Or would it be lower where it's almost zero? So think through that for yourself. As I look through this particular graph, I notice the slope at the beginning is very, very steep, and then it slows down and levels off almost to zero. So the way that we would indicate that, I'm going to use this a different color just so it's not too confusing, but the increase in slope here would indicate a high slope, and then as I move to the end here, it's getting very close to zero. So the way that this looks, and notice it is a very smooth, it would actually look just like that. All right, next example. Example number 3. We've got a straight line. What would be the slope of this? If I had asked you, in fact, I did ask you in the very beginning of this lesson, I said, okay, what is the slope of a flat line? What is that slope? And how would you graph that? How would you graph 0? It literally would look a straight line on the x-axis, and that would be the end of story. The slope at this spot is 0. The slope at this spot is 0. The slope at this spot is 0. The slope all the way along this, the slope is 0, and so we'd indicate that by a line. All right, how about this last example that I have in front of you? The last example that you see here is I have a slope that is going down. It's decreasing. It's a negative number. And what do you know about the slope of a line? Is it the same all along that line? Does it change? At one point, is it steeper than another? It is the same. It's the same slope, and in this case, it's decreasing, so it's constantly a negative number. One number, that's negative, that's all you need to know. We don't really even need to evaluate what exactly that number is. All I need is that, hey, it is one number that's negative. It's the same slope at the first spot as it is the third, as it is the fifth, as it is the 10th, as it is whatever. Any spot along there all has the same slope. Good. Now, hopefully tonight you've had a chance to look through this video. You've had a chance to process what this all means. Tomorrow in class, we're going to be practicing how to graph derivatives more specifically. We'll do quite a bit of practice, and hopefully you'll get your bearings then. For those of you that are new to this, this will be a little tricky, let's just put it that way, especially since you're still just trying to figure out derivatives. Feel free to come in and get extra help, but hopefully the time in class will provide enough assistance to all of you. All right, I'll see you tomorrow.